test paper and then start writing the solution. And please, whatever you write in the test paper, submit it as soon as possible within 5 minutes. Okay. So these are the test papers. Now we are going to start. New topic, that is nature of CH bond. Good evening. So nature of CH bond, you can see that this carbon or haloalkane is like this. Now we already know that this H means halogen, which is more electronegative than carbon. That means, do you anyone any idea about electronegativity? What is electronegativity? Sneha, Hamza, and Nafisa. What is electronegativity? So see, electronegativity is the property of any element which attract or withdraw the bonded electron. That means this since this is more electronegative X, so it will slightly displace carbon's electron towards itself. So there will be delta negative charge and there will be delta positive charge. That's why this is polar bond or polar molecule, we can say polar. The bond is polar, that means charge bond. So there are some questions which can be asked is arranging increasing order of. The first question is bond length. Arrange in increasing order of first bond length, then the second is bond enthalpy, then the third dipole moment. This all term you have already studied in class 11, dipole moment. And what is the compound in which of which we are going to arrange? Which compounds we are going to arrange? So basically this is the list of compounds: CH3F, CH3Cl, CH3Br, CH3I. So you are going to arrange this A, B, C, D, 4 compounds in increasing order of their bond length and then bond enthalpy and then dipole moment. Can anyone do this? This is very easy question. Any answers, Sneha, Nafisa? Nafisa, am I audible to you? Hamza, please do respond if you
Yes,
don't
sir.
know. Yes, sir. What does this mean, Nafisa? Can you solve it or no?
No, sir.
No. Is it in increasing order? Sneha, are you solving the first one or the second one or the third one? See, bond length depends upon atomic size. Basically, you can see this CH3 is similar in all. This CH3 is same. Now that this bond length depends on fluorine, chlorine, bromine, and iodine. And you know that if element is bigger, the bond length will also be. If the element is larger in radius, the bond length will also be large. Are you getting my point, Nafisa, Hamza?
Yes, sir.
So you can see if this is very small, that means its bond length will be very small. So if you are going to solve for bond length, CH3F will have the lowest bond length, and then CH3Cl, and then CH3Br, and then CH3I. Why it is so? Because you know that this is halogens, fluorine, chlorine, bromine, iodine. This is in group. Down the group, size increases, and size increases, that means bond length also increases. Are you getting my point? So this is the order of bond length. Please write it. And do you know what is the bond enthalpy? Bond enthalpy is basically uh, the energy required to break this bond. You can think of like this: bond dissociation energy. So how much strong it is? So there is a relation: bond length inversely proportional to bond enthalpy or bond energy. So the bond which is uh, smaller will have higher value of bond enthalpy. Nafisa, Hamza, Sneha.
Yes, sir.
Okay. So please do the second one. Are you done with this?
Yes, sir.
Okay. Did you solve the second one? Bond enthalpy in increasing order.
Yes. Yes, sir.
Okay, what is the answer for bond enthalpy? So the bond enthalpy will have opposite because bond length inversely proportional to bond enthalpy. So what will be the answer in increasing order? CH3I will have the lowest value of bond enthalpy, then
H3I,
CH3Br,
CH3Br, CH3Cl, and
CH3Cl,
CH3F.
and then CH3F.
Yes,
Now
sir.
we are going to talk about dipole moment. Do you know what is dipole moment? Dipole moment has a formula mu is equal to q into d. This d represents basically bond length and q is charge that develops on the atoms. Like this is fluorine, most electronegative element. That means this will withdraw electron and it will have delta negative and delta positive charge. That depends upon its electronegativity. If it is very highly electronegative, that means the charge will be highly negative and highly positive. So in the same way, if we are going to arrange for this dipole moment, so the lowest dipole moment have a value of CH3I, then CH3Br, then CH3F, and then CH3Cl. See what happens here. Wait a minute. I think this CH3F, CH3Br. Okay. This is the order of increasing order of dipole moment. You know what this? If you are going through electronegativity concept, this should be here and this should be here. But experimentally, we found that the dipole moment of CH3Cl chloromethane is greater or more than dipole moment of fluoromethane, because the bond length increases here. That's all. Please write it.
Yes, sir. Finish.
Sneha, Hamza, and Fatima, you are again late. Please write it. Hamza, are you done with this?
Yes, sir.
So Fatima, we started from here. Nature of X. Please do respond. So nature of X is basically the bond is polar because X is more electronegative than carbon. So it will withdraw or attract some bonded electron, some basically towards itself. So there will be delta negative and delta positive. And we will have some question. We had some question like arrange in increasing order of bond length, bond enthalpy, dipole moment of CH3F, CH3Cl, CH3Br, CH3I. Bond length, you can see CH3 are common in all those four compounds, but this will depend on fluorine, chlorine, bromine, and iodine. If the atomic size increases, bond length increases. So fluorine has the smallest size, that means smallest bond length. So this is the order of bond length, and bond length is inversely proportional to bond enthalpy. The one which has lowest bond length will have the highest bond enthalpy. Okay, Fatima. Please take a screenshot and let me know so that I will. So now we are going to have another topic, that is methods of preparation, MOD in short form. Methods of preparation of haloalkanes. First, we are going to study about the methods of preparation of haloalkane. In this organic chemistry, what we need to learn is the first, its nomenclature, and then we will talk about physical properties. Then this methods of preparation. What is the method? How we are going to prepare? Like if the chapter's name is haloalkane and haloarene. So first of all, what is the method for preparation of haloalkanes? What is the chemical properties of haloalkanes? That means we are going to react this haloalkane with different compounds and see what is the result. And then uh, this is it about it. Like if we are going to study about alcohol, so first we are going to learn about its nomenclature, and then what is the method of preparation, different methods of preparation of alcohols. Then what is the physical properties of it, physical properties like melting point, boiling point, solubility. And then what is the chemical properties of alcohols, like this. So first the chapter starts from here, like methods of preparation of alcohols. So the first method is from methods of preparation of haloalkanes. So the first method is from alcohols. That means we are going to prepare haloalkane from alcohols. So there are different methods, 6 different methods of preparing haloalkane from alcohols. We will see how we are going to deal with it. Just write the topic and let me know. Are you done with this?
Yes, sir.
Now see what happens here. So the first method is from alcohols, and in this alcohol ROH react with HCl in the presence of ZnCl, in the presence of ZnCl2. And what happens here, you can see this OH will be replaced by this chlorine, and it will form RCl. You can see it will form RCl, and there is hydrogen, and this OH will combine to form H2O. You can see OH is replaced by chlorine, so this is haloalkane or haloalkane, and this hydrogen will combine with this OH to form H2O. So please write this. If we have CH3 CH2OH combined with HCl in the presence of ZnCl2, what will be the product? You are going to write it. Again, this is very important to note. Please concentrate here. This HCl, concentrated HCl plus ZnCl2 is known as Lucas reagent. This is Lucas reagent. So when we are going to use Lucas reagent in alcohol, it will give haloalkane. And this H2O is called byproduct. This H2O is called byproduct. We deal only with main product, that is haloalkane. So please write it. Please let me know the product. And whenever you are going to write the product, write its IUPAC name. That will help to for the formation of your basic concepts of organic IUPAC, not organic. It will help you to strengthen your IUPAC names. Any answer?
CH3, CH2, Cl plus H2O.
CH3, CH2, Cl. This is very easy. Plus H2O. Yes. What is its name? Chloroethane.
Yes, sir.
Chloroethane. Yes or no? Everyone done with this?
Yes, sir.
Sneha, Hamza, Fatima, please do respond. No audio. Okay. Now see, basically, can anyone tell me which one is more
Little
stable?
bit up.
What you just said, Hamza?
So can you do a little bit up? Yes, 1 minute.
Oh, wait a minute. Are you done with this?
No, sir, 1 minute. Done.
Done. Writing. Increasing order of stability. I just want to know whether you can solve it or not. CH3, CH2 plus. CH3, 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 CH3. Please do this. Can anyone solve it? Nafisa, Hamza, Sneha, just don't waste time. If you don't know how to solve it, just let me know, please.
No, sir.
So what? Why are you waiting, all of you? Why were you waiting? Please just respond as Nafisa responds. See what happens. Can you? This is you know that carbon on carbon when there is positive charge. This is called carbocation. Yes or no? Carbocation. Can and please let me know the degree of this carbon. C positive. C positive.
The first one is
Degree of this
primary. The
primary.
second
That means
one
1 degree,
is secondary.
2 degree,
And then after that, the third
3
degree.
degree.
Yes, sir.
Now you can see this CH3, that means methyl, has plus I effect. Has plus I effect. Now you can see plus I effect. That means electron donating tendency. Electron donating tendency. This positive means this is electron deficient. This positive means electron deficient. How you can see? You can see there is 2 hydrogen and this is bonding. Carbon should make 4 bond to make it self stable, but here is only 3 bond. That means 6 electron in its outermost shell, but it should be 8 electron. That means this is electron deficient. And beside this, adjacent to this CH2 plus, there is CH3 group which is supporting it by donating some electron by one side, from one side, and this is supported by 2 and this is supported by 3 CH3. So which one will be more stable? This one and then this one, because this C plus, then CH plus, then CH2 plus are electron deficient. They require electrons, and the attached group to this CH2 plus is CH3, which means basically it is supported by one CH3, this is supported by 2 CH3, and this is supported by 3 CH3. So this will be the order of stability, or we can write directly 3 degree is more stable than 2 degree, than 1 degree. Got it?
Yes, sir.
Please write it.
Yes, sir. Finish.
Very good. Now I'm going to write a point about Lucas reagent. Everyone done with this? Fatima, why are you not responding? At least send message in chat box where you are getting it or not. Hamza, are you done with this?
Yes.
Sneha? Now I'm going to write a point which is very important. Please write it. The reaction of primary and secondary alcohol. Requires reaction of primary and secondary alcohols with HCl requires presence of a catalyst, comma Z and Cl, with tertiary alcohol, with tertiary alcohols. The reaction is conducted simply by shaking the alcohol. Wait a minute. Wait a minute. Please. By shaking the alcohol with concentrated HCl at room temperature. So basically, why it is so? Tertiary alcohol will give tertiary carbocation, 3-degree carbocation, which is very stable. So concentrated HCl will mix with that, and by simply shaking it at room temperature, we can get haloalkane. But in case of primary and secondary alcohol, we require presence of catalyst ZnCl2 along with concentrated HCl. Because primary and secondary alcohols or primary and secondary carbocation will not be that much stable. Let me know when you are done with this. This was only the first
Yes, sir. Finish.
method of preparation of haloalkane from alcohols. Hamza, Sneha. Hamza, are you done with this?
Yes, sir.
Okay. Now other methods will be also there for the preparation of you can see the second method B. From alcohol. In alcohol, you are going to mix NaBr and H2SO. That will give RBr. That will bromoalkane. That will be for bromoalkane along with NaHSO4 plus H2. So what happens here? Just replace this OH with this bromine. So OH will be out from here and Na and then HSO4. This will break down into two parts, H plus HSO4 minus, and this will combine. This is plus, this is minus. This will combine with this negative positive and form NaHSO4, and then you can see H plus, and here it is minus. It will form this, and this is plus, so this will combine with this. So it's very easy. Just we don't deal with this. These are all byproduct. Basically, just replace OH by Br. You will get bromoalkane. So I'm going to give you a question: CH3OH plus NaBr in the presence of H2SO. Please write the product.
CH3Br.
CH3Br. So the answer is very easy, CH3Br. And along with this will be same. These are byproduct, NaHSO4 and sodium hydrogen sulfate and water.
Yes, sir. Yes, sir. Finish.
Now C part. Three moles of ROH plus PX3 will give 3 moles of RH and then H3PO3, where X is only for chlorine and bromine, not fluorine and iodine. This reaction is only for chlorine and bromine. Now I'm going to explain this. This is very easy. If there is ROH, now see ROH, PX3. This is PX3. So you can see ROH, ROH, since 3 moles of ROH and ROH. And here you can see this is reacting with PX3, X, X, and X. So what happens here? Just omit this. So you can see H3PO3 is this, and then RX, 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 that means 3 moles of RX. So in this case also you can understand like this. Just replace this OH with X and you will get the main product RX. So I'm going to give you a question. Please write the name of the, please write the product. Everyone done with this? This reaction is only for chlorine and bromine. Let me know when you are done with this.
Yes, sir.
Very good, Sneha. What is the product? The product I'm going to write will be just replace this OH with the Cl. And what will be the byproduct? H3PO3. Is this your answer, Hamza?
No, sir.
What was your answer?
Sir, I couldn't find the answer.
This is very easy. Just replace OH with haloalkane. Sorry, halogen. So if I'm going to give you a question like this, just don't go on diagram like it is tough or like this. Write the product, please.
Sir, we'll replace the OH with PR.
Yes, it's very easy. Just replace this. And what will be the byproduct? H3PO3. It's so easy. Sneha, Fatima. Please let me know. Let me know when everyone done with this. Hamza, are you done with this?
Yes, sir.
Okay. Now the D part is basically ROH alcohol react with PCl5, phosphorus pentachloride. Then see what, again replace this OH with Cl and there will be POCl3 along with HCl. These are byproducts. So if I'm going to give you a question like this, CH3, CHOH, and then CH2, CH3. Write the IUPAC name of the product also.
sir, we'll replace the OH with Cl.
Yes, just replace this with this CH, and then what is the name? Just write the product and write its name also.
Yes, sir. Sir, it's 2-chlorobutane.
Yes, CH3, then replace this OH with the chlorine and then CH2 and then CH2 along with this POCl3 plus HCl. So you can see this is basically 2-chloro butane. Any doubt, Hamza?
No,
No,
sir.
sir.
Now see, the fifth part is basically ROH reacting with red phosphorus along with X2. This X is only for Br2 and I2. So it will form Rx directly. So if there is any question like this, CH3OH and red phosphorus along with I2, what will be the product? CH3I, iodomethane. Please write this. And the last one, F, you can see ROH reacting with thionyl chloride, SOCl2. Just replace this again and it will be RCl along with SO2 and HCl. And this method is effective. This method is very effective for the preparation of haloalkane, as the two byproduct is in gaseous state and we don't need to purify for haloalkane. You can see this is in gaseous state, so it will evolve out from the container and only we will have pure haloalkane. So this is very effective method for the preparation of haloalkane. Please keep it in mind.
Yes, sir, finish.
Everyone done with this? Hamza, Neha, Fatima. Hamza, are you done with this?
Yes, sir.
Very good. Now see, these are all the methods of preparation of haloalkane from alcohol. Now the second method is basically from hydrocarbons. From, oh wait a minute, from hydrocarbons. So everyone knows about hydrocarbon. What is hydrocarbon? If I'm going, can anyone tell me what is hydrocarbons? Nafisa. So this is very easy. Hydrocarbon, that means the compound in which only hydrogen and carbon is present, that is called hydrocarbon. So hydrocarbon, you know, saturated and unsaturated. There are two types of hydrocarbon: saturated hydrocarbon, unsaturated hydrocarbon. So basically saturated, that means alkane, and unsaturated, alkene and alkyne. So we are going to prepare haloalkane from alkane first and then alkene. So you can see from alkenes by free radical halogenes from alkenes by free radical halogenes. So you have already learned about this reaction in class 10. You know about substitution reaction, anyone? What does this halogenation means? So see, what is halogenation? Whenever the term like this will come, that means addition of halogens. If the term will be hydrogenation, what will it mean? Nafisa, if halogenation means addition of halogens, what does this means? Hydrogenation,
Addition of hydrogen.
addition of hydrogen. So see, basically we are going to do halogenation. That means in alkanes, not alkenes, sorry. So we are going to add halogen in alkanes. So see, this is the method how we are going to prepare. We have CH3, CH2, CH3. This is alkane, that is propane. Reacting with Cl2 in the presence of H nu, that means sunlight. So what happens here is very easy. This chlorine will be broken and one of the hydrogen from any carbon, you can see hydrogen can be replaced from here. Hydrogen can be replaced by chlorine and hydrogen can be replaced by chlorine. So first of all, I am going to replace the hydrogen on the right hand side and remove one hydrogen and add one chlorine like this, the first product, and then again of the middle, and then again on the left hand side CH2, Cl, and then CH2, and then CH3. So this is basically example of substitution reaction. You know what is substitution? Everyone knows about it.
Yes, sir. Replacing.
So what you need to do is like this, just replace one hydrogen with the chlorine and the byproduct will be HCl, because you can see hydrogen is coming out from here and one of the chlorine will combine to form HCl as byproduct. Nafisa got it.
Yes, sir.
And what I want to say is this, please write the name of all the product. You will get a new concept, which is very easy.
So first one is chloropropane.
Very good. What is the name of the second? This is chloropropane. One chloropropane or chloropropane.
Propane.
What is the name of the second product?
2-chloropropane.
2-chloropropane. Very good. What is the name of the third product? What? What you just said?
Chloro,
Chloropropane.
propane.
Yes, sir.
So you can see first and third are same. So these are identical product. These are identical. So only two product from this reaction. Only two product. This and this are same, na?
Yes, sir.
And everyone concentrate here. The first and third have same name. That means it is identical. So only two product. Either you can take this and this, or either you can take this and this. Yes or no?
Yes, sir.
Please write it. Done with this.
Yes, sir.
Now I'm going to give you another question. Please write all the possible product. Write all the possible product.
So first one is chloroethane.
Okay, how many product there will be?
Only one.
Only one. Very good. Now do the rest.
So second one is chlorobutane, and two products can be formed.
Only two product. Right?
Yes, sir. Yes, sir.
Okay, very good.
And third one, three products can be formed.
Write all the name.
Yes, sir.
What is the name?
The first one,
See, I'm going. Any answer from Hamza, Hamza and Sneha?
chloroethane.
Wait a minute, Nafisa. Hamza,
Yes, sir.
Sneha, what is the answer for the first one? You can see, you can replace chlorine from here
Sir,
on the left hand side,
how
or
do
you
we know
can.
which one can we replace?
You are going to check it. We can replace this, not check it. You can replace basically any hydrogen, singly bonded carbon, any hydrogen. So just see, hydrogen, and hydrogen, and hydrogen. So you can replace any one of this. That will mean same. Hamza. So I just replaced one of the hydrogen and got this. And in the second, I just replaced one of the hydrogen this and got this. But you can see both will have the same name. That means only one product is possible. Okay, Hamza.
Yes, sir.
Please do the rest one, Hamza.
So the next one will attach the carbon to the second one. We can attach it to the third one also and the fourth one also, right?
See, the first one, if you are going to write the first one like this, CH2, CH2, CH3. If you are going to attach chlorine here and here, that will mean same. That will mean same. Both are same. And if you are going to attach here and here, this will be same. So only two products. You can take
Sir,
here.
we can make it 2-chlorobutane.
Yes, 2-chlorobutane and 1-chlorobutane. If you are going to replace chlorine as a hydrogen for 4 times, like 1, 2, 3, 4, there will be a repetition of product. That means same product. If you are going to write chlorine here, replace hydrogen here by chlorine, and here, that will be identical here and here. So only two products. In the same way, if you are going to replace hydrogen from here, this will be same. So we will consider only one product. 1, 2, and then 3. This will be same. 2 and then 1, 3. So 3 products are will be possible in this, 2 product in this, and only 1 product in this. Got it, Nafisa?
Yes, sir.
Sneha, why are you not responding? Are you done with this? Network connection, okay. Let me know, Hamza, when you are done with this. Okay, Sneha. Hamza, are you done with this? Very good. Hamza?
Yes, sir.
Okay. Now see, the second preparation of haloalkane from hydrocarbon, that is alkene. So from alkenes, the first one was from alkanes, and now it is from alkenes. So see, from alkenes, how we are going to prepare. So the first part is addition of hydrogen halides. Addition of hydrogen halides. Halide, that means X, and hydrogen, that means H. So there are two rules which we have already studied it in class 11. The first one is Markovnikov. And the second one is anti-Markovnikov. Kharash effect, also known as Kharash effect. Peroxide effect, also known as Markovnikov and Kharash effect, and then peroxide effect, also known as. These are two peroxide effect. Method 2, there will be reaction of hydrogen halides with alkene. Now see, and these rules are for asymmetrical alkene. Symmetrical alkene and asymmetrical alkene. Now see, if we have CH3 CH double bond CH2 and there is only HX, and the reaction will the reaction will proceed, and CH3 CH double bond CH2 and there is HX, and on the arrow it is written something like peroxide in presence of peroxide. So whenever there is peroxide, presence of peroxide, that means anti-Markovnikov. And whenever there is nothing written on the arrow, that means Markovnikov. This is Markovnikov. Now see how we deal with this. It's very easy. Can you tell me in HX which is negative part, which is positive part? So how we are going to decide which is negative and positive? So the one with highly electronegative and the one which is more electronegative is negative part, and the one with less electronegative is positive part. So this is delta negative because halogen is more electronegative than hydrogen, and this is delta positive. Got it or not? Yes or no? Please tell me. Couldn't hear you, Nafisa. Hamza, you are not audible, Nafisa. Is there any problem?
Sir,
Sneha?
can you
Okay,
hear me
now.
now?
Yes.
Sir, can you
So,
say again?
Yes. What I was saying is that when alkene react with hydrogen halides, there will be two conditions. On arrow, there will be nothing written, or it will be written like no peroxide. There is no peroxide. And when alkene react with hydrogen halide in the presence of peroxide. So when in the presence of peroxide, that is anti-Markovnikov, and when absence of peroxide, same reaction, alkene with hydrogen halides in absence of peroxide, that is Markovnikov. So according to Markovnikov, negative part of the addendum will go along the double bond to that carbon which has lesser number of hydrogen, and positive addendum will go along the double bond to that carbon which has greater number of hydrogen. So it's very easy. We are going to add this. We already know carbon makes 4 bonds, and in order to add something on that, we need to break old bond. Are you getting my point, Hamza, Nafisa?
Yes,
Carbon
sir.
can make only 4 bonds. So according to Markovnikov, you just need to recognize whether it is Markovnikov and whether it is not Markovnikov, or whether it is anti-Markovnikov. And how we are going to recognize? First, see alkene, that's good. Hydrogen halide. Now, if it is written nothing or written no peroxide or in absence of peroxide, that is Markovnikov. And alkene and then hydrogen halides in the presence of peroxide, that is anti-Markovnikov. So according to Markovnikov, negative part of the addendum will go to the carbon along the double bond which has lesser number of hydrogen, and positive part of the addendum will go to that carbon along double bond which has greater number of hydrogen. So we are going to write its product CH3 and then CH, and then double bond will be broken and it will be CH2. Now you can see hydrogen, lesser hydrogen this, so X will come to this and greater hydrogen will come to this. So the product will be basically CH3, CHX, and then CH3. Now again this is delta negative, this is delta positive, and it's very easy. Anti-Markovnikov, this is opposite of Markovnikov. Negative part will go to that addendum which have greater number of hydrogen, and this. So the product will be CH3 and CHH and then CH2 and then X, or we can write CH3, CH2, CH2X. So it's very easy, very easy. Please write it.
Yes, sir, finished.
Everyone done with this? Hamza, are you done with this? Okay, I'm going to give some questions to you. You're going to write the name of the product. Please do all the questions. I'm waiting for your answer. And then let me know.
sir, how do we do this?
The first one, did you complete the first one?
No, sir.
No, sir. Is this
Should we
alkene?
just?
This is alkene, yes or no?
Yes, sir.
This is hydrogen halides. Halides, that means
Yes, sir.
fluorine, chlorine, bromine, iodine. And
Yes,
there is nothing written on the arrow. That means this is Markovnikov.
Markovnikov. Yes, sir.
This is also Markovnikov.
Should we just like
Yes.
label it? Oh, I thought. Okay.
See what in HCl, which is negative part. In HCl, which is negative part, hydrogen or chlorine? What do you think?
Chlorine.
Chlorine, more electronegative, delta negative, delta positive. Now
Yes,
come
sir.
to this alkene. Can you tell me along the double bond, there is a carbon and there is a carbon, which has more hydrogen? If you are going to draw the structure, you know this will have one hydrogen and this will have two hydrogen.
Yes, sir.
Yes or no?
Yes,
So
sir.
negative part will go to that carbon which has less number of hydrogen, and this will go to that carbon which has more number of hydrogen. So the
Yes,
product will be like this. Yes or no?
Yes, sir.
This is anti-Markovnikov. Please do it.
Yes, sir.
Done.
Yes, sir.
What is the name for the first one? 2-chlorobutane, and for the second one?
Bromopropane.
2-bromopropane or bromopropane?
Two
Second one or
bromopropane.
third one?
Second one.
Okay. Hamza, any answer from you?
So
Yes. Yes, Nafisa. You can see this is also Markovnikov. So you either you can write here, either you can write here. Both will be same because number of hydrogen on both carbon along double bond is same. That's why this is symmetrical
yes,
alkene. Now see, this is peroxide. That means anti-Markovnikov.
anti-Markovnikov.
This
Yes,
is
sir.
peroxide, anti-Markovnikov. But you can see this is symmetrical. This is symmetrical. It won't affect. So you can write anywhere. Are you getting my point?
Yes, sir.
Either you can write here, either you can write here.
So bromobutane.
2-bromobutane, not bromobutane.
Two
This is 2 bromobutane.
Yes, sir.
Hamza, any answer from you?
Yes, sir. The double bond will go.
Double bond, where double bond will go?
So that double bond in the second carbon.
Of which number you are talking about? First, second, third?
So the last one.
This.
Yeah.
So double bond is here and double bond is present here also. So which double bond you are going to break?
This one, the second one, not the benzene.
Right one. Yes, this benzene ring is aromatic and it is very stable, so it's
It's
not
an aromatic compound, so it will
yes
not be broken.
break. So easy. So see, this is peroxide, that means anti-Markovnikov, and you know that negative part in anti-Markovnikov to go to that carbon which has more number of hydrogen. So just like this, CH2 and then CH, and double bond will be broken, and negative part will go to that carbon which has greater number of hydrogen, and positive to that carbon which has lesser number of hydrogen. Yes or no?
Yes, sir.
Okay, please do this and let me know.
Sir, where does the H from the HBr go?
H from the HBr. You can see H from the HBr.
The last
This
question.
was only CH. Yes or no?
Yes.
Now it is CH2. It is CH2, CH and H.
Okay, so
This
CH2.
HBr. Now you see this HBr. Negative part will go to that carbon along double bond which has more number of hydrogen, and this positive part will go to that carbon along double bond which has less number of hydrogen,
Yes.
according to anti-Markovnikov. Please do the last one. You can see this is Markovnikov, so this is negative part, this is positive part.
Sir,
Negative part,
it will go to CH.
this carbon which
Yeah.
has lesser number of
Yes, sir.
hydrogen, Markovnikov, and like this. So the
H will
product
go
will be
H3.
so the product will be like this.
CH3, right?
Double bond will be broken. Wait a minute, I just did a mistake. Br will be here, and it will be like this: hydrogen, 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 and hydrogen also. Yes or no?
Yes, sir.
Please write all this and let me know.
Yes, sir. Finish.
Everyone done with this? Sneha, Hamza, can I move to the next part?
Yes, sir.
Now see, there is another method of preparation of haloalkane from alkene. That is addition of halogens. Directly we add halogens in alkenes and we will get haloalkane. So how does it happen? CH2 is here, and we are going to add Br2 in the presence of CCl4. So in order to add something in this compound, we need to break one of the bond. So you can see this will be CH2, and then Br, and then Br. This is how we are going to prepare from alkene. Please write it.
Yes, sir. Finish.
Finish. So is there any doubt from the today's
No, sir.
lecture? No, not at all. So I'm going to give you a question. Please write the name of the IUPAC name of the product.
Sir, two,
Yes.
2,3 bromobutane.
2,3 dibrom, not bromo. You can see the product will be like this: bromine here and bromine.
Yes, sir. Yes, sir.
So 1, 2,
Oh, okay, sir.
2,3 dibromo
Dibromobutane.
butane.
Yes, sir.
Hamza, are you done with this? Hamza, are you done with this?
Yes, sir.
Okay, everyone done with this? So this is it for today. I will see you in the next class. Please be prepared and always revise organic chemistry.
Thank you, sir.
Thank you. Thank you, all of you.
Sir, I can leave now?
Yes, yes, Hamza.
Okay, sir. Assalamu alaikum.